Hello friends, welcome to Engineering Works 247. Today we are going to discuss the RCC reinforced cement concrete. So let's start with it. Here is the important note. In LSM or limit state method, partial safety factor applied is two times, such as first for material and second for load. And in working stress method, factor of safety is applied only once, which is for material only. So next we will see the methods of RCC designing. It is the condition just before collapse up to limit that member is safe to resist external loads and also gives proper service throughout life. In limit state method, first is safety and second one is long life. First is limit state of strength. In this, bending or flexure is considered, torsion is considered, shear, tension, compression, and non-repairable cracks due to fatigues are present. In the limit state of serviceability, the durability, deflection, corrosion, fire resistance, vibration, repairable cracking due to fatigue, shrinkage, and creep, these are considered. Here, limit state of collapse in flexure or bending. Here we can see that when RCC beam is made up of concrete plus steel. So here flexural member subjected to transverse loading. Here you can see simply supported beam with support 1 and support 2, and it is subjected to a UDL of W kilonewton per meter. When the load is applied to the beam gets bent. Here is the diagram how the beam bends. On upper side the compression occurs and at the bottom side the tension occurs. So here is the basic difference between concrete and steel which is used for construction purpose. For concrete it is the brittle material. Here we can see the grade of concrete which is stated is M20. In M stands for mix, and for 20 we can say it characteristic compressive strength which is in Newton per mm square for 20 28 days of curing. This is done in the cube of size 150 mm. As per Indian standard, the minimum grade of concrete used in the normal condition is M20 and minimum grade of concrete used in seawater condition is M30. And when we talk about the steel, we can see that steel is a ductile material, or we can see density of steel can be calculated as 7850 kg per m cube. So modulus of elasticity of steel is 2 into 10 raised to 5 MP, or we can say 200 GPa gigapascal. Grades present in the steel are, first one is mild steel, or we can say it as Fe250, and second one is HYSD steel, or we can say it as high yield strength deformed bar. The grades present in these are Fe415, Fe500, and also Fe550 is used. The steel is notated by Fe415. In this Fe415, Fe stands for iron and 415 stands for characteristic strength, or we can say yield strength. So here the next point discussing is the location of reinforcement bar, or we can say where to provide the steel bar. When we see the cantilever beam, here you can see the cantilever beam and it is loaded to UDL of W kilonewton per meter. So here you can see the neutral axis where when the beam is subjected to UDL, the beam bends in this manner. On the top of the beam there is tension and at the bottom of the beam compression is present. So here is the reinforcement where we should provide reinforcement. So here due to the tension is present at the top of the beam so that we have to provide the reinforcement above the neutral axis. And when we see the simply supported beam subjected to UDL, the deflected shape you can see here. On the upper side there is compression present and lower side there is tension present. So we have to add the bars in the tension side. So here we can see that here reinforcement bar provided will be below the neutral axis. So here the basic formula that we will be using while calculating the area of the reinforcement. Here according to IS 456 2000 EST minimum upon B into D, or we can say breadth into depth, is equal to 0.85 upon Fy, where AST minimum is equal to minimum area of reinforcement. B, or capital B, is equal to width of cross section of beam. D is equal to effective depth. We can say that D minus D naught. Here capital D is the total depth and D naught is the cover provided to the beam. Fy is the yield strength of the steel. Thank you. We will stop here and next part will be discussed in the next lecture. Thank you.